आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, in this question it is given that let f be a function, okay, with continuous second derivative and f0 is equals to f dash of 0 is equals to 0. Then we have to determine a function g by gx which is equals to fx upon x, okay, for x not equal to 0, and it is x equals to 0, for x equals to 0 it is 0, okay. Then which of the following statement is true, okay, which of the following statement is correct? We are given four statement. Option A is g has a continuous first derivative, okay. Option B is g has first derivative, okay. G is continuous but g fails to have a derivative, okay. And g has a first derivative but the first derivative is not continuous, okay. So first of all, I'll write the given thing in the question, given function in the question, then we'll try to solve it, okay. So gx is a function given to us in the question and this condition is given to us in the question, okay. f0 is equals to f dash of 0 is equals to 0, okay. Now first of all, we'll check whether this gx is continuous or not. So how we can check? Okay, we'll check a limit x tends to 0, okay. We'll check a limit x tends to 0, okay. We have function fx upon x, okay. Now if we just substitute 0 in place of this, so f of 0 upon x will be 0, and this is f of 0 is what? 0, it is given to us in the question and it is also 0. So here I am getting what? I am getting 0 by 0, okay. So this function doesn't exist, so what I'll do? I'll use L'Hospital rule, okay. Using L'Hospital's rule here, okay. Using L'Hospital rule, I'll get here, okay. This rule states that here if this condition exists, so let me write it first. Limit x tends to 0, okay. We just derivate numerator and denominator, so derivative of fx will be f dash x and derivative of this x will be, derivative of x is 1, okay. Now limit x tends to 0, okay. F dash x value it is given to us in the question, it is 0 and upon 1, so it is equals to 0. And since it is equals to 0, we were checking whether this gx it is continuous or not, so I got here 0, so I can conclude that here my function gx, okay, gx is continuous, okay. Gs is continuous at x equals to 0, okay. Okay, we have proved that gx is continuous, okay. Now according to question we also have to check whether this is differentiable or not, okay. So how to check this? To check whether this is differentiable or not, if my 0 plus g of 0 plus is equals to g of 0 minus, then if this condition here, this condition if it is true, then I can say that gx is differentiable, okay. Now check, if I'll check for 0 plus first, okay, 0 plus, so we are having a direct formula for this. Let me write that formula. It is equal to limit, okay, h tends to 0, f of, here I am checking for 0 plus, so 0 plus h upon h minus f of 0 and whole divided by h, okay, for checking whether gx is differentiable or not, okay. So limit h tends to 0, okay, 0 plus h is h, so f of h upon h and f of 0 was 0, okay. So I am just skipping this step, f of 0 is 0, so basically I can write here h square, okay, because this value will get 0, so I can write this, okay. I have just directly skipped that step. Now what I'll get here? So look, if I'll just substitute 0 in place of h, I'll get here 0 and 0. It is not defined, so I'll use L'Hospital rule, which I have told earlier. I'll use it here. So using that rule, what I can conclude here, limit h tends to 0, I can write it as f dash of h, and twice of h. Okay, using that rule I can rewrite this as, okay, this. Now again if I'll put h equals to 0 here, I'll get 0 by 0. It is again not defined, so let's use this rule again. On using L'Hopital rule again, so I'll get limit h tends to 0 f of double dash of h by 2. Okay, now again if I'll just substitute h equals to 0 here, on substituting h equals to 0, I'll get 0 by 2. Okay, this is 0. Here I'm not getting any non-defined value like this. Here I'm getting a proper value which is equals to 0. So my function for 0 plus is equals to 0. Now for checking differentiability, I'll just consider 0 minus now. Okay, I'll have limit h tends to 0. Okay, f of here I'm having 0 minus, so 0 minus h minus of f of 0 upon minus h and whole divided by 0 minus h. Okay, now here I can also write 0, it is same. Okay, now this value, it is equals to 0, it is given to us in the question. So on solving this, I'll get limit h tends to 0 f of minus h upon h square. Okay, I've just moved this here. I have multiplied these two. Okay, simple mathematics. Now in the next step, if I'll substitute here my limit h tends to 0. Okay, if I'll substitute 0, I'll get 0 by 0. Not acceptable because it is not defined, so I'll use L'Hopital rule here. So what I'll get here, limit h tends to 0. Okay, f dash of minus h, and in denominator I'll have 2h. Again it will be in form of 0 by 0, so not acceptable. Again I'll use L'Hopital rule, so I'll get limit h tends to 0. Basically we are comparing whether this function is differentiable or not. We have proved that this function is continuous. It will be f double dash h upon 2. Okay, now it will be equals to 0 by 2. Okay, or it is equals to 0. So look, what was my g 0 plus it was equals to 0, and my g 0 minus it is also equals to 0. So I can therefore g 0 plus is equals to g of 0 minus, which is equals to 0. So I can conclude that this function, I can conclude that gx is differentiable at x equals to 0. Okay, so we have also proved that gx is derivative at x equals to 0 and gx is also continuous at x equals to 0. So when we look at option here, it is clearly visible that statement, okay, it is continuous first derivative and option B has first derivative. Okay, so both are true. And here option C was, it is option C, g is continuous but g fails to have derivative. Option C is false. And option D, g has first derivative but the first derivative is not continuous, it is also false. So 1 and 2 are correct answer. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।